This video will describe the menu system available on the PicoScope, and then a series of additional videos will be available for describing each menu in more detail. The sine wave being displayed is being generated from the internal arbitrary waveform generator, and is a sine wave with a frequency of 100 kHz and an amplitude of 900 millivolts. The signal that has then been applied to the channel A input, and the range control has been set to auto, so it automatically selects the best vertical range to give the best vertical resolution and most accuracy for any measurement. And here in fact we can see it's selected plus or minus 1 volt. So we could then use the range control to manually set the range. The menu system has been divided into 3 toolbars. So the third toolbar is for the channel setup. So here we can see the channel options for channel A, and in fact the input is a default ×1 probe, but if for example we connected a ×10 probe to the input, we could select a ×10 option, and then this would automatically scale it to ×10, so the voltage values would read correct. The second item down is resolution enhancement. So the digitizer is an 8-bit digitizer which would give up to 256 vertical levels, but we can, by oversampling, increase the number of bits. So for example we could select 11 bits, and we can see now we've got improved vertical resolution, so we can make more accurate measurements. Similarly for each channel we've got scaling, so if we had a special probe we can change the scale factors and the offsets, and there's an analog offset, and finally at the bottom there's a low pass filter. So for example if I turn on the 1 kHz low pass filter, we can see it has again removed any noise on the signal, which again could improve the vertical measurement accuracy. The third icon along is the coupling. So at the moment we've got DC coupling, so we can go to AC. If we've got any DC content on the signal, that would remove that. And the third option is for high bandwidth signals to terminate into 50 ohms. So if I select that, in this case it will halve the amplitude of the signal because it's coming from a 50 ohm source. The next set of icons along are for the additional channels. So this is a 4-channel instrument, so we've got channels B, C and D available. So I'll turn on channel B and give it a range control of plus or minus 1 volt, and here we see now channel B is being displayed with its scale factors on the right hand side. In fact we can see the signal, it's the same signal but it's been passed through a low pass filter, so it's been attenuated. So I'm going to increase the range control 100 millivolts, so now we can see it in more detail, and in fact we can see the signal has gone through the filter and been delayed in time, so we can see a delay offset in time here. Moving to the main menu bar along the top, this is a Windows pop-down menu system. So if we select File for example, it gives a very window type pop-down. Here we can open either waveforms that have been saved or any instrument setups, and similarly we can save waveforms and save setups. So for example if 2 engineers use that particular instrument, they could both have their own different setup available to be loaded. And as a special option there's a power up setting, so again if an instrument is used in one application it can power up in a chosen set of settings, so you can save the settings and then it will automatically power up into that front panel setup. The third item is a default reset. There is a printer available, so we can do a print preview and then we can print the screen image to any printer. The second icon along is the edit menu, and here we can copy screen images or text to any Windows application. So for example we could copy this image to Paint and then it could be saved, or we could copy the voltage values as text to, for example, Excel, and again we could save that data. The third menu along is the Views menu, and here we can add and remove views from the display. So the current display is the scope display, which is the standard amplitude against time. The second option is the spectrum, where we can produce a FFT waveform, and that would display frequency against amplitude. And the third option is the XY, and I'll go ahead and select that, and we can see the effect. It opens a second panel, and this is channel A versus channel B, displayed as an XY display. If we want to remove any particular panel, we can select the panel, and then in the Views menu we can select Close, and that will remove that particular display panel. Or we can turn individual channels on and off. So here we've got channels A and B being displayed, so I could hide channel B, or I could reinstate it. Moving down the menu system, we could also auto-arrange the two views. So if I select auto-arrange, again this opens two panels and provides an offset. So here's channel A with its scale factors, and here we have channel B scale factors. Any channel again can be turned off. So from the range control we can turn off, for example, channel B. So now we just have the channel A displayed, and again under Views menu I could reselect auto-arrange and put it back to the original display. Finally, at the bottom we have the View Properties menu, and this produces a pop-up on the right hand side, and this is the current acquisition. So the sample interval is 200 picoseconds, and this corresponds to a clock of 5 gigasamples, and the memory across the waveform being displayed is 500,000 memory locations. The second set is the arbitrary waveform generator. So here we can see the sine wave, 100 kilohertz, 900 millivolts again with zero offset. The third grouping is the channel A input. So we can see it's in blue, and this is highlighted in blue. So we see channel A plus or minus 1 volt and DC. This again can be minimized to keep the area available for the waveform display to be always maximized.